welcome you all on the series of how do we do the fatty analysis and fatty acid or oil analysis. First of all, the experiment we are going to do today is standardization of NaOH. Why the standardization of NaOH? Why is it needed? The question is, and the answer for this question is, the NaOH is always present in a solid form and it has a property of hydrophobicity, which says that it loves the water. It is hydrophobic. It absorbs the water from the moisture. Whereas second property is it reacts with CO2. This all make it unstandardized. The solid form of NaOH unstandardized. For that, we make a solution of NaOH and standardize it. How do we standardize it? The next question arises. How do we do that? And that's where enters the standardized solid substance, a standardized solid substance that is known as primary standard, set as our primary standard. And for this reaction, we have primary standard as KHP. What is KHP? KHP is potassium hydrogen phathalate. Potassium hydrogen phathalate. We take potassium hydrogen phathalate with distilled water, potassium hydrogen phathalate with distilled water, and add a phenolphthalein indicator to it. This is all the solution we make in a conical flask, iodine flask. Okay, and this please make sure that your KHP, that is potassium hydrogen phathalate, should be completely dyed, and add then it into water with the phenolphthalein indicator. Then what should be titrant? Here the titrant is what we are standardizing, NaOH. NaOH is our titrant. Now what we basically do, take a conical flask, add a kph, water, phenolphthalein indicator, fill the burette with NaOH. Now we start titrating with the NaOH and shake it vigorously. After every adding the point, switch it. Continue the process, and after that, at the end, we will stop it, and we will get a faint pink color. That's the end point of our reaction. From the faint pink color, we will get a burette reading of NaOH. That is a burette reading, or a volume of NaOH occupied in that whole reaction. We know the mass of kph we have taken. Now, in order to get the desired or a standardization of NaOH, the formula we use is, please take a note of the formula. Normality of NaOH or a molarity of NaOH is equals to mass of KHP upon burette reading, that is what we get the burette reading, multiply by 0.204. Okay, now here we will put our KHP mass that we know the priorly. We will put the burette reading that we got from that, and secondly we will multiply the burette reading with the 0.204. Why 0.204? If you see the KHP mass, you will see it is in a 204.2. Then why that 0.20? That's the conversion, gram to milligram. Now next, after getting this, if we have created a solution of 0.1, and after putting the value of mass of KHP and burette reading, we are getting the 0.1, then our solution is standardized. Congratulations, your experiment is complete. While if we aren't getting it, we are getting the some or a different value of concentration, then make sure that you standardize it again and make the necessary changes. Okay, this is why, or this is how we perform a reaction. Now many questions might arise here. Why only a KHP? Are there alternatives? There are alternatives, but they are not more preferable. While KHP is considered as a gold standard, primary standard for a reaction of standardization of NaOH. Make sure that you follow this series, and we will come soon with the next experiment.